morning, guys. I'm impressed you guys are very on time. So many people arrived so early. Okay, a few things before we start today's lecture. Who wasn't here on Monday? Okay, so just so you know, we kind of do this format. We print out a lecture slide, fill the blanks and stuff. Okay, so if you don't know what's going on, I won't really repeat the rules. You can ask your classmates, all right? Second thing, a good news, we got a TA. I'm the happiest. So I'll have her be here on Friday. She'll introduce herself, and she'll be the one helping you guys out for the project. Okay? So now instead of in LA, we have a TA. Another thing, so who has formed teams? Awesome. So you guys can, who has submitted the team form? Not yet. So if you form the team, you can go to the project folder in Angel, and you can just click this team information. Just a really simple Google survey. So you fill it out. Make sure your team has a GitHub repository. Put the link here. Put the team member's name. So I only put 5 spots for each team to make sure you don't exceed 5 members. Okay? No less than 4 either. 4 to 5. Alright, so that will be for the team, and I will expect you to have your teams formed by Friday 5 p.m. Okay? If your team, you don't have a team by Friday 5 p.m. or you feel like you don't really care about who you're going to be with, don't submit the form and then I'll pick it for you. Okay? So that's going to happen Friday 5 p.m. Also, because on Friday we will talk a bit more on the project that I mentioned on Monday. So make sure you will sort of read through the project description. I think it's a bit long, so you can just read. Let me see. The first few slides. Oh, and there's this main character in the project. I don't know how to name him, so you guys can name it if you think of any awesome name to send it to me. I just put XXX, super creative. So then you can just read through, let me see, around page, wow, 5, okay? 1 to 5. With your teammates, you guys can split, like you're gonna read which page or which section. And if you feel like there's any parts that you're not sure what I mean, or you don't know what I'm expecting, let me know on Friday, okay, when we go through the project. So that would be it. Before we get started, okay. Start the lecture. Today's lecture 2. Give you a little bit of outline for today. So just a heads up, you might want to pay attention for today's lecture because we will wrap up chapter 1, and you know something might happen on Friday. So, okay. So what I'm going to cover today, just to talk a bit more, just a tiny bit more on relational data model that we mentioned at the very end on Monday. And we will talk through the levels of abstraction, the concept levels of abstraction and data independence. These 2 will kind of be the emphasis for today. Okay. And we will talk about the queries in the database management system and structure of DBMS. If we have time, we might move on to chapter 2, but I'm not sure. Because last time I kind of ended a bit earlier, so today I just prepared a little bit more, but I'm not sure whether we'll get into chapter 2. But we'll definitely finish it. Okay, so this is from last time. We talked about relational data model. It has the main concept of relation and schema. So I want to clarify, I made a mistake last time. I said, and I think some of you pointed it out, I say relation can be a table. We also call it as a row, right? But actually not. Relation refers to the table itself. And we have other names for the rows and columns in the table. Okay? Just don't get confused. I'll get in a bit more. So before we move on to the next slide, imagine, let's go to the super basic. If you're going to store data, say in Excel spreadsheet of students' information, what will you put on the first row? names of the column. What? Okay, the names of the column. Okay, so normally we do it not like, we don't put the names of the columns vertically, right? We kind of conventionally, we just put it in row. So row by row, you put the student's information following whatever names of the columns that you put at the very first row. Make sense? So here, anyone remember what this is?
Schema.
Yes, it's a schema. It's like a TV show, like answering game kind of. So yeah, this is a schema. And last time I said, maybe login is the last login time. No, I figured it out. It's email. It's just email. So this will be the example that we use throughout the textbook. Okay. So imagine we put this in Excel spreadsheet. Then you will put the very first cell on the very first row as the SID, right? Second cell in the very first row, name, and login, age, and GPA, right? That's how you're going to put it in the table. So, whoa, it's going to be, yeah, Mac and Windows not compatible. So you're going to put it kind of like this, and you fill out the information right here, right? So right here, I was supposed to, you can see different fonts, so it was supposed to be the schema. But anyway, so schema, what do you think? It's a what for describing a student? Close. Yeah, it's a template. So for every student that you enter the information, you will follow whatever that's defined in the schema. Okay? You will follow the data type, you will follow the names of the columns that you just defined. So what do we call for the whole table, as I said earlier? We call it a relation, right? So we call the whole table a relation. So how about each row? What do you think we will call it? Yes, it's a record. Okay. How about each column? We just say it will be the names of the columns. Fields. It can be fields or... Okay. So just remember, here is just kind of some terms that we'll keep reusing throughout the semester, so you don't want to get confused. So the whole table for the relation, okay? And for each row, we call it the record. So one student is a record, and every student has several attributes. Okay? Okay, so there's actually way more about relational data model that we can learn, but for chapter 1, we just stop here. And then we will learn a bit more in later chapters. Okay, so now I just want to make sure you kind of know what is the basic idea for a relational data model. Okay, then let's move on. So there's one really important concept called levels of abstraction in DBMS. Basically, we separate the DBMS into different levels, and each level takes care of different things. And later on, we will talk about what benefits you have by having different levels, taking care of their own tasks. So let's start from the very top. As you can see, the red part, we have little boxes. We call it the view, okay? So on the very top level, we have multiple views. For example, on eLion, you can view the student's view. So you will have the information that students can access, and faculties will have the faculty view. Okay? Even though everyone shares the same database, same data, but then because of the views defined differently, you retrieve different kinds of data that you can see on the browser or on different kind of interface. Okay? So this level we call it the external schema. That's where the users view the information. Okay? So external schema describes how users see the data. Okay? Then move on is the conceptual schema. The conceptual schema, it's more like what we just talked about, the relational data model, how you're going to organize your data. Okay? So it defines a logical structure based on data models. We'll get in a bit more in the later slide. Then finally, the bottom is physical schema. Okay? Different schema takes care of different things. You want to make sure you when you see a task, you figure out which level it should go to. Okay? So let's go through one level by level. Let's start from the conceptual schema. We also call it the logical schema. Okay? So as we said before, the relational data model, it defines different logical schema. So it describes the stored data in terms of the data model of the DBMS. So in the relational model, what do you think the conceptual schema will describe?
All the relations.
Yeah, all the relations. So fast, I can't even find who said it. Okay, so relations. What do you think relations would describe? As we said earlier, it describes the students. The students are what? And tables can be what? Entities? Yeah. Is this too easy, or you guys agree? Okay, so yeah, in relational model, the conceptual schema would describe the relations, and relations can be entities or relationships. Okay, as we said on Monday, entities can be each one of you. Okay, you guys are students. Students can be entities. Also, the courses can be entities. So you are taking this course. That's the relationship between you and this course. Make sense? Okay, so here's an example of what conceptual schema takes care of. That's the schema that we just saw, right? How about physical schema? So physical schema summarizes how the relations described in the conceptual schema. Okay. And actually stored on secondary storage devices such as disks and tapes. So if you see the task like this, it says the relations, which are the tables, are stored as on order files. That's what the physical schema will take care of. Okay, other schema won't care about it at all. Or you can say, oh, the second column of the student relation is indexed by a B tree. So these things are taken care of by physical schema. If you don't know, B tree is just a data structure. Okay. Let's move on to an external schema. So external schema is a collection of one or more what?
Views.
Yeah, the views. Okay, so it allows data access to be customized at the level of individual users or groups of users. Okay. So one thing to note is that records in the view are not stored explicitly, and it's computed as needed. What I mean by that, you can take a look at this example here. So this example is the course information. So you will have the course ID that's stored as string, right? And then enrollment means the number of students enrolled. Do you think we will create a table just for storing number of, like one column storing number of enrollment? Or we would rather have just compute it from, how do I say, selecting the students who actually enroll in that course and then just somehow count it, right? So you don't actually have to store one more information about the number of enrollment in the table, but then when you want to show it on the external schema, you have other indirect way that you can just compute it. Make sense? Okay. So that would be different levels of abstraction. So why do we need levels of abstraction? That's because we want to have a conceptual data independence. So I showed earlier, we had different kind of schema right here, right? So between different levels, we have different kind of data independence. For example, between external schema and conceptual schema, we have this data independence called logical data independence. So what it does is that it can predict from changes in logical structure of the data. For example, web developer, they might take care of the external schema, right? Deciding what will be shown on the web pages. So when something happens, when something changes in the conceptual schema, do you think the web developer has to know? Or as long as the API, the ports are the same, then different developers, when they change the design of conceptual schema, external schema doesn't have to know. Okay? So another data independence is between conceptual schema and physical schema. We call it the physical data independence. Okay? So This is very similar to the idea of the logical one, but in the sense that when physical schema changes, maybe it changes the way of indexing one kind of attributes, or the changes the way of allocating the space in the disk, this kind of thing. So when something happens in the physical schema side, then the social schema doesn't even have to know. Okay, so that's for data dependence. Next will be queries in the DBMS. So since we have data, it doesn't just sit there and you don't use it, right? You definitely want to ask some questions and get the answer from the database. So when a user asks different kind of questions, we call these questions what? Queries. Okay? So, some residues still. Okay. So we have different kinds of query languages. So a query language is used to post queries. Okay. Who can tell me what is the most famous query language? SQL. So what does it stand for? Structural. Yeah. Almost. Structural query language. Stands for, so it's SQL. Okay. So it supports a rich class of queries, has contributed greatly to the success of relational DBMS. For queries, for query languages, there are two really important concepts that we will learn later, maybe next week or 2 weeks later, that will define the formal logics for a query language. So they are the relational algebra and relational calculus. We'll spend quite a lot of time there. So has anyone seen how SQL looks like? SQL, we call it SQL. Okay? Don't say SQL, say SQL. So here's an example. For example, we repeat the question that we raised in the previous slide. What is the name of the student with student ID 53688? Okay, an example, you don't have to memorize it now, but I think it's super simple, you can understand by just reading through it, right? So let's start from here. So you want to say from which relation that you want to take the information. Okay, so this is the students table, right? The students relation, so you say from students. And what is the attribute you want to select? The name, right? So you want to select the name from the students relation. If you don't define the criteria here, which is the where, it will actually return you all of the names stored in the students relation. But because we state the criteria here saying, I only want the student's name whose SID is equal to this one, then it will only return who? Smith. Yeah, Smith. Okay, so this is just an example of this SQL query. And we will talk a bit more, I think, chapter 5. So now just give you an idea of how it looks like, and you will learn about it after the first chapter. So this is for queries. Let's talk about transactions. So a transaction is any one execution of a user program in a DBMS. We can think of an example for transaction. Can you give it more like concrete? Like a real life example. Yeah, so you go to the bank or you go to the ATM and you want to deposit money. That one action from start to the end is a transaction. Any else?
Logical unit of work.
Hmm?
I mean, logical unit of work.
Logical? What does it mean? Like an example for a transaction. Yeah, booking airline ticket. Okay? So the whole action itself is called a transaction. So for having a transaction, we have to make sure that the transaction doesn't ruin the database or the transaction is successful. So there are four requirements for a transaction. Okay? The first one is called atomicity. Judging from the word, who can think of what does it mean? What it means for a transaction? Yeah.
It cannot be break down smaller.
Yeah, it cannot be broken down smaller. So, or more formally, we say the idea of atomicity for a transaction is either or nothing. All or nothing. What it means that if part of the transaction fails, the whole thing you just don't do it. For example, let's imagine if the bank works this way. If you say I want $1,000, now you want to withdraw $1,000, and it's just in imaginary world. It will give you $1 by $1. Okay. So let's say if the transaction suddenly just fails, you just got 300, and the ATM machine's like, nah, I'm gonna stop. I'll give you next time. Can you do that? No, right? So it's for atomicity. Okay, transaction is all or nothing. You cannot just stop it there and like, see you next time. So another one is consistency. So consistency, who can guess what it means? Yeah.
Do you consistently return the same records?
Yeah, so when you have queries, yeah, you put the same queries on the same database, and you should return the same answer. Is that what you mean?
Yeah.
Yeah, so that's one. Another one is that if the data stored in the database, they are all valid in the sense that it all fulfill the constraints we define. For example, all the students' IDs are stored as strings, or let's say we have a maximum amount of budget and the department isn't exceeded, then after a transaction, the consistency should remain. So you cannot say, oh, after one transaction, I just break the rule because I want to. Okay, it has to be the same. So it's moving from one valid state to another. Okay, still satisfying the constraints. The third one is called isolation. Anyone can explain what you think isolation means?
Exclusion from the concurrent solution.
Yeah, elaborate a bit more. So,
Alright.
what do you mean by that?
So, management deposit, two people share the same account, and one is trying to deposit, one is trying to withdraw, and two transactions should be isolated from each other.
Yeah, so what Jason was saying is that isolation means if you have multiple transactions happening concurrently at the same time, the end result of the database should be the same as if you do those transactions sequentially. Okay, you cannot be like, if we do it together, it will have a different result. Okay, so that's for isolation. The last one is durability. So durability means once a transaction is committed, it should remain the same. Okay? Who can think of an example for that? A counterexample of durability. Yeah.
It can handle a lot of transactions at once? For a short period of time?
So durability is more like when once the transactions are committed, it will stays the same, remains the same.
You lose power.
Hmm?
You lose power and
Crash
you
happens.
suppose the software crashes, then still the data.
Yeah, exactly. So for example, let's say you guys are all signing up for courses, right? And suddenly the Penn State registration system shuts down because power's off. You cannot be like waking up next morning, oopsie, didn't register for that. It cannot be like that. So it has to remain the same. Okay, recover from any kind of crashes. Okay? So for these four, what do you guys think it will call?
Asset.
Yeah. Yeah. So it has its properties. Okay, it's ACID. Okay. Let's get to the most exciting slide for today. This one. Okay, so this is the structure for a DBMS. If I say this part stores the data, then what do you guys think the blue part is? The whole blue big box. Yeah,
The software abstractions?
which is? Yeah, it's the DBMS. Great. So the blue part is the DBMS, okay? And sitting on top of database. Okay. So what do you guys think will be the input for a DBMS? Yeah. So it's SQL. Okay. It goes in the DBMS. So when a DBMS takes a SQL comment, what do you think will be the first thing that should be done? Before we even execute, yeah.
You separate like its commands.
What separate the command?
Like you figure out what data, what table we're looking at, what attribute we're trying to get, and what attribute we're searching by.
Yeah. So that's the process of understanding the command, right? Or
Yes.
okay. So what do you think understanding the command will mean?
Query parsing and.
Yeah. So it's
It will check
parsing.
for from and yes. After that, it will check for where condition, and after that, it will check for respective attributes it needs to fetch. And that entire process is called parsing.
Mm-hmm. So if you are parsing the query, or we say the SQL command, so it's like a process for evaluating the command, right? So for the whole red part, we call the query evaluation engine. So the SQL command goes in, the query will be evaluated. And in the evaluation engine, we have different little parts, okay? So as we just said earlier, the first part, who has taken a course of compiler? Okay, so in a compiler, that you will parse the codes, right? You write the code and it will get parsed first. So we will need a parser. Okay, like the example we just had earlier, you have select from where, that kind of SQL command. So when it gets in first, it has to be parsed so that it can, in order to get understood. So, let me see. So after the SQL command is parsed, we will move on to an optimizer. Okay. So what the optimizer will do is that it will generate an execution plan. Okay. Execution plan, because even for the same query, you can have different kinds of approaches of doing it, of retrieving data from the database. So the execution plan will be generated. Then the plan will get executed by the plan executor. Okay. And right here we also have an operator evaluator. We will talk about this a lot more later on in the semester. So as I said earlier, we have the same commands. It can be done in different ways. So you guys know operators, right? So even for the same command, it can have different kind of combinations for operators, and that will hugely affect how the performance is. Okay. So now it might still be a bit vague, but we will move on later in the semester. So the whole thing, the whole part of the query evaluation engine is sitting on top of files and access methods. So the files and access method, it supports the concept of files. So here it says files, but actually we can think of as the records or relations that we just talked about earlier. okay? Different kind of data model will have different kind of files. But for relational data model, that takes care of the records, relations, and stuff. And for the files, we can think of it as a collection of pages. You guys have learned the concept of pages, right? So the whole file and access method sits on top of a buffer manager. So as I just said earlier, because the files, they have a collection of pages, so the buffer, what it does is that it actually brings pages from the disk, okay, to the main memory as requested. So every time you have a query, then maybe you will have to bring in different kind of pages to the main memory. Okay? And the whole buffer manager sits on top of the disk space manager. Okay? So what the disk space manager does is it will just manage the space on the disk. Yeah.
You said you use a buffer manager again? You said you use a buffer manager again?
Explain the buffer manager. Okay, so buffer manager, it brings the pages from the disk to the main memory. So up until here, these are like the basics for the DBMS, but to make things more secure, DBMS also have the other two parts. So on the left-hand side, the green box is the concurrency control, okay? Oops, I'm not wrong. So the concurrency control, it has two components. Okay, the first component is called transaction manager. Yeah.
What do you mean by pages when the buffer manager returns a?
Oh, so in the disk, things are stored, you know, the concept of pages.
Okay.
So the buffer manager takes care of bringing the pages to the main memory, so that when we have the query, it will request different, you will need different parts of the data being bringing into the main memory, then later will return back as the result for the query. Okay. So the transaction manager, it ensures that transactions request and releases logs. So anyone took operating systems? Yeah, so you know that you have to take care of the logs. Okay. So this is what the concept of logs. So transaction manager, it will make sure that the transaction, they will request or release the logs. And who will be granting the logs? That will be the log manager. Okay. So the log manager will keep track of the logs and also make sure it can grant the logs. Okay. So the two components together, we call them the concurrency. And as we said earlier, when we talk about the durability, we mentioned that when the power is off, you want to make sure things can get recovered once it comes back, right? So on the right-hand side, we call the recovery manager. So the recovery manager, it maintains logs to restore the system to its state before the crash happens. Okay. So this is just the big picture of the structure of DBMS. Okay. Until here, any questions so far? Yeah.
So what exactly does the transaction manager do?
The transaction manager, it ensures that the transaction will release or request the logs. But the log manager is the one giving the grant. Yeah.
So what is the log for? Is it the transaction manager generates logs or something?
No.
Just stores.
They just give the logs. Yeah. The transaction manager is not the one granting. Anything else? Yeah.
So this log which you speak of, is this actually the data which is accessed or the data depending on which we are accessing the data? I mean, let's say the query is select name, the student ID is say 1.
Yeah.
So the log will actually be on 1 or on the name. That's my question. I mean, let's say there are two different queries which use the same student ID, but they access different data. So So can this be executed concurrently or is it not?
Do you mean where the lock will be? I think it has to depend on, let me think. Depend on different data models, it should have different kind of locks. So you were saying when two students have the same,
No, what I'm asking is, let's say there are two SQL commands.
yeah.
Both of them are based on one student ID. Let's say one command is select name, the student ID is one.
Yeah.
The other is select, say, date of birth, the
Uh-huh.
student ID is one.
Ah.
So can these commands be executed concurrently or will, because they don't need to be
Yeah.
concurrent?
I see. I think it depends. It has to depend on how. Yeah, it depends. As long as they don't conflict. Yeah, I'm not sure. Any other questions? Okay, so now we have a really exciting thing. We have question time. I think you guys already know the answer. Because there are all examples from previous slides. So, remember the levels of abstraction? Yeah.
Yeah, sorry, to go back to that last slide real quick, can you explain a little bit more about the lock manager, like what exactly it's doing?
Yeah, sure. The lock manager, so transaction manager, it makes sure that the transaction will request and release locks, right? And for the lock manager, it is the one granting the locks. So transaction manager doesn't have the permission of just giving the transaction locks. So they together control the concurrency, but then they take care of different jobs.
But what's the actual lock, like making sure that the wrong data doesn't get displayed or something? Or?
So the lock, you can think of it as when a transaction gets the lock. So it will be granted, it's permitted or allowed to access some parts of the data, while the other one has to wait for the lock. When it doesn't have that, it cannot access it.
Gotcha.
Yeah. More question on this one? Okay. Get back to question time. So for the first two, I think you guys remember. When we talk about relations are stored as what kind of files, or we say a certain attribute indexed by a certain data structure, which schema takes care of it? Physical schema. Okay? So how about the second one? When we define schemas as this way, we have students that has SID that are strings, name is strings, logging is strings, or courses having these attributes. Which schema takes care of it? Logical or conceptual? Okay. Lastly, this one defines what a user can perceive based on the user's role. Yeah. Okay. This is like one of the favorite questions to be tested on in exam. Not that hard, right? Okay. Next one. Don't know whether it will be a bit trickier, but we'll see. Okay, so we talk about different kinds of data independence we have. There are two data independence, right? Logical and physical. Okay? So for each example, I want you to figure out whether it's a logical data independence or a physical data independence. Okay? Logical is L, physical is P. So let's start from the first one. So we say the ability to change the logical schema without having to change the external schema. Yeah. That is logical. Okay, this one is kind of obvious. How about the second one? Let's say we are using a new storage device and yeah. Okay. How about we say we want to change the indexing approach from hash to
Physical.
okay. Yeah.
Can you explain that?
Don't get upset. Remember.
Software type of data structure do you use?
Remember we said earlier, let me see. How do I move back and it won't show you? Here, right? So for the physical schema, it is the schema that takes care of, the task includes how you're going to index the column, the attributes or any kind of data, right? So when we just change the way of indexing, it's between the physical schema and the conceptual schema. And because it's between the physical schema and the conceptual schema, that's for physical data. Okay? So here, oopsie. Didn't see anything. Okay. So, how about adding new entities? Logical, right? Okay. Last one. Using different file organizations or storage structures. Okay. Might test this, so. Yeah, I think I did finish really quickly. So that was for chapter 1. Okay? Yeah.
But can you explain adding new entries? How's that work? Yeah.
Entities? Oh, so adding new entities. Let's go back to our favorite. So when you add new entities, that's for conceptual schema, right? Because let's say, let me think. So in a university database, we have students, we have faculties, we have courses. So let's say today we want to add an entity. What entity do you think we can add? Classrooms. Okay, yeah, I was thinking about pet. Terrible. Okay, let's say we add classrooms. Do you think the external schema has to change the way they retrieve data? No, right? So that's for logical data. Okay. Any other questions for chapter 1? Yes.
When we talking about transactions, so it's the execution of what you're saying in the program. So it can be as simple as like SQL query in the program, like access
yeah.
the information on the like student information, what you
Yeah,
so,
be a simple version of it.
added 2 or 3 queries in a transaction and complete each of them one.
Why?
Or the program has to be written that way that they don't like kind of conflict with each other.
You mean the queries conflict with each other? Yeah, in what sense? What are the examples for queries?
I can also.
Okay.
I can also.
So if they conflict, yeah, I can't think of what will be.
Or it's kind of normal execution program line to not be used for.
Yeah, then that one query itself will be a transaction happen. Any other question before we move on to the basics of the basics for chapter 2? Yeah.
So going back to the second, we use storage devices in previous question right?
Yeah.
The end user does not have to consider about that because it's all the memory value will take care of how it stores the files.
Mm-hmm.
The schema will not change it, and the end user it will not be restricted.
It will not.
So it should be a logical.
But also, no, using new devices, but also like for the concept, so using new devices, the conceptual schema does not,
Yeah, even physical schema does not happen.
But then physical schema takes care of how it allocates the spaces, the spaces. So they have, yeah. Okay. Any other question? 5 minutes left. Let's talk a little bit about 2, I think, is a super important chapter in the whole textbook, and also for your phase 1 in your project. You will heavily use what you learned from chapter 2. Okay. So, I think we discussed in the very first class about entities and relationships, right? So, for this kind of data model, having entities and relationship, we just call it the entity relationship model. So that's ER model. Okay. So, what is the thing that is a real-world object distinguishable from other objects? Yeah, it's an entity. Okay. So, as we said earlier, for students, we have different kinds of what describing it. Yeah, so an entity is described in the database using a set of attributes. All right, so here's an example of a graphical representation in an ER model. Okay, so we use rectangle to represent an entity. So say we have employees. And for each employee, we will have different kind of attributes describing the employee, and we use this, what's it, oval, to describe the, to represent the attributes. Okay. Then, yeah. So then, because one entity it can have multiple attributes, so then let's say an entity has a set of attributes. Okay. So some more basics on the ER model. So we call an entity set a collection of similar entities. So to make it a bit clearer, we can say a student is an entity, but a group of students, because they are similar entities, so we call them entity set. Okay? So all of the entities in an entity set have the same set of what? Yeah, so the attributes should be the same. Okay? You cannot be like this student has this set of attributes and the other student has different sets of attributes. The attributes can have different values, but they all have the same attributes. Okay? Another concept that we will get in a bit more next time is that each entity set has a key. Okay? So the key is the minimal set of attributes whose value uniquely identify an entity. For example, what do you think will be a good key for a student? The student ID, right? You won't use the student's name as the key because so many people have the same name, right? So that's the concept of key. And then key, we can get it a bit further next time. Yeah?
Is an entity set just a table, or are there multiple entity sets within the table?
Yeah, entity set is one big table.
Okay.
Yeah. Yeah, I think that's it for today. So